Did you know that you matter? You have space. You have mass. Therefore, according to chemistry, you matter. Today we will be talking about matter, elements, compounds, and atoms. Oh my! Hopefully by the end of this video you should be able to describe the differences between an atom, a molecule, and a compound, and use those words fairly fluidly between each other. For today's timeline, we are looking at words that matter. So first and foremost, just kind of explaining what a particle is, what an atom is, molecule, compound, element, diatomic, and matter in general. So a bunch of definitions for what those things are. Then we're going to be putting those words together in order to apply their new meaning in context. So a particle, let's start with a particle. Brainiac, nerd, geek, nah, you're smarticle particle. So a particle is a blanket word that includes both atoms and molecules. So if you were going to try and describe an atom or a molecule, you could use the word particle interchangeably. Particle is just kind of like your scapegoat word. If you don't know what to say, you can say particle because you're technically right. It encompasses basically everything. So one single atom is a particle. If you have multiple unbonded atoms together, those are also particles. If you have a molecule, that's a particle. And if you have multiple different molecules in a mixture, even, that would be a mixture of particles. So particle is your blanket term that encompasses both atom and molecules. If we're moving on to atom then, okay, well, if we know what a particle is, what is an atom and a molecule then, Mrs. Duckonta? Well, let me tell you. An atom is one single particle. Great explanation, right? No, we're going to keep going. So that includes the protons, neutrons, and electrons. So if you haven't seen my previous video yet about atoms and their structure, please go back and watch that. Link is in the description below in order to understand protons, neutrons, and electrons first before we move any farther with this lesson. So any of the periodic table symbols. So if you're looking at your periodic table, ta-da! If you're looking at your periodic table, any of these guys are your atoms. They all have protons, neutrons, and electrons. Those are your atoms. We can say, okay, I just put up a few examples up there, but I represent it also by this gray circle. And that represents one single particle or an atom in this case. If we're going to take an atom and bond it with another atom, we now have a molecule. So a molecule is two or more of the same or different atoms attached together. They're stuck together via something called a chemical bond. So that is literally sharing of electrons or a transfer of electrons between atoms. So because of that, they are sharing a bond. They're kind of stuck together at that point. So if we have two of the same atoms together, we call them elements. These are the same atoms bonded together. That would be like these two gray circles up above. Those are representing a molecule that happens to be an element. We can also have molecules that are called compounds. A compound is when you have two different atoms bonded together. So that would be like what's right above my head right here. We have an orange atom and a blue atom, two different colored circles. Since there's two different atoms, this would be a molecule that happens to be a compound because they're different. So again, let's go over this. A molecule is when you have two or more, you could have 3, 4, 5 atoms bonded together. And that is what makes a molecule. If you have two of the same, it's a molecule that happens to be an element. If you have two or more that are different, it happens to be a molecule that is a compound. So let's go into the element a little bit more. We call this a pure substance, only the same kind of atoms, only gray atoms, only blue atoms, only orange atoms. They're only going to be the same color, same type of atom. If we only have two, so remember from the previous slide, we said that a molecule could have two or more. So we could have 3, 4, 5, 10. We could have any conglomerate number of atoms that are the same or different, bonded together to make a molecule. But if we have two, if we have only two of the same atom, then we call that a diatomic. There are a few diatomics that you should recognize. O2, N2, F2. Basically, if you look at your periodic table, it is all of these guys. They kind of make a 7 right there. All of those guys, plus hydrogen over in this corner. Those are your diatomic elements. In other words, you're never just going to see N. You're never just going to see one gray atom of N by itself in nature. It just doesn't happen. Now, N could pair with an orange atom or a purple atom, could pair with something else, or if it pairs with itself, it's always going to come in pairs. It's going to travel in pairs. So in that case, we call those diatomics. In other words, they never go to the bathroom alone, like ladies, right? Women never go to the bathroom alone, safer in pairs, safer in groups. So again, if we're looking at nitrogen as our example here, that nitrogen is paired with itself. Again, nitrogen can pair with other atoms. It doesn't have to just pair with itself, but when it is paired with itself, we call it diatomic. We would never just see, so imagine that this N is gone right there. We would never just see one singular N by itself. If it were by itself, there would be another N that comes and attaches to it to save the day and make it diatomic. Another example of this would be our O2, oxygen. So when we refer to oxygen, like what I'm breathing in right now, that oxygen is O2. Never would I just be breathing in O. That doesn't exist. Now, oxygen can pair with other things too. It doesn't just have to pair with itself, like H2O, water. In that case, oxygen is paired with hydrogens. In this case, we would never see oxygen just by itself, so just one O. That's when, if it was by itself, with no other H's nearby to bond with, or no other something to bond with, then it would bond with itself and make O2, an element, a diatomic element. Let's move on to compounds. Compounds, as mentioned before, is a type of molecule, just like an element is a type of molecule, but a compound has two or more different elements bonded together, different atoms bonded together. So we talked about water on the previous slide. There's also the example of like rust. If you have Fe, which is iron, and O, which is oxygen, and those two bond together, you make rust, iron oxide. Those are two different types of atoms from the periodic table, two different colors, and that makes a compound. So check it out. If you look at the iron oxide above my head, you can see that there are 2 irons, 2 Fe's, and 3 O's, 3 oxygens. So if we pair those all together, notice that there's these little stick things between them. Those are representing the bonds that are holding them together. When we have those bonds holding them together, then we end up with a compound. They are different atoms bonded together, a compound. This one right here is representing water. The white spheres are representing hydrogen, and the red sphere is representing oxygen, H2O, 1O. There are different atoms, different colors, therefore this is a molecule of water, which is more accurately further described as a compound of water because they are different types of atoms bonded together. So a way to remember this is that all compounds are molecules, but not vice versa, because a molecule could also be an element, which would have to be the same type of atoms and not different. So let's give it a try. The one above my head. Hopefully you should be able to identify that with some specific words. We just talked about it. It is a molecule, which is more accurately described as a compound because there are different atoms. Then which picture would represent an atom here? It would be the one that has the nucleus, protons, neutrons, and electrons. Again, this planetary model is incorrect, but we use it just for the sake of using it to model an atom. Okay. How about having two of the same atoms together? You could call this a molecule, but if you were being more specific, you would call it an element. And because it is chlorine, and chlorine is within this little group right here, this little 7 that I pointed out before, that would make it a diatomic element, more specifically. You would never see chlorine by itself. How about this guy right here? We have a bigger red atom bonded to, that's what the sticks are showing, bonded to these 5 green atoms, whatever those happen to be. Since there are different atoms present and there are more than 2 bonded together, we can still say that this is a compound, different atoms, or we could call it a molecule. So if we wanted to be specific, we would say compound. Overarching, all of these are molecules thus far, with this one being the atom still. How about this one? This is not a picture, so there's no pretty picture with colors, but what we can see is Zn. Zn stands for zinc, and what we have is Br. Br stands for bromine. We have 2 different atoms, 2 different periodic table particles. When we stick those together in a bond, that's what it means when we put them right next to each other like that, that they're bonded. So when they have a bond between them and there are 2 different atoms, we would call that a molecule, more specifically a compound, because they're different. Now what if I got rid of the Zn and all I had was Br2? Br2, Br falls within this 7 over here that I pointed out earlier. So Br2 means there's 2 of them and they're the same. So that means that it's an element, and specifically it's a diatomic element. Last but not least, take a look at that guy right there. What would be the first box? The blue dots. What could we call those? You could call it an atom, or the atoms, right? There would be more than one. You could call them atoms. You could call them particles, right? But we can't call that one a molecule. Molecules, by definition, have to have 2 or more bonded together. In that first box, we only have 1 spheres floating around. How about the middle one? The middle box has green spheres attached to each other. Now those green spheres are the same. What we could say then, since there's 2 or more, is that this is a molecule, and since they're the same, it's an element. Now we don't know which kind this is, but if it fell within this little 7 right here on our periodic table, we could call them diatomic. How about the last box? The last box is showing that there are 4 atoms all together, bonded, but they're different. The middle one's brown, the outside ones are yellow. So we have different atoms, we have 2 or more. So we have a molecule that's more specifically a compound. Now technically, technically. All of the ones on the slides can be classified as particles. As mentioned before, a particle is your blanket term for atoms or molecules. So all of these up on the slide are technically particles. Let's go ahead and try modeling this. A molecular model kit is rather useful and highly recommended if you are going to go into any kind of chemistry career, future, college. They're great. You can model them, kind of visualize what's going on at a molecular level, a molecule level, when we have two or more atoms bonded together. The basic color scheme for these guys are red. Red spheres represent oxygen. Black spheres represent carbon. And white spheres represent hydrogen. So we're just going to use these three for now. There are all kinds of colors in a molecular model kit, but we're going to build the following. So first and foremost, we want to build an atom. Well, let's see. That's an atom. That would be an atom of carbon. That's an atom. That's an atom of oxygen. Has its own protons, its own neutrons, its own electrons. And this would be an atom of hydrogen. It has one proton and one electron. Let's build a molecule. A molecule, by definition, has to have two or more atoms bonded together. So a bond is going to be represented by these little connector pieces here. And they can just kind of like pop into your little model kit pieces. So if I took this hydrogen and I put another hydrogen on the other side, I now have a molecule of hydrogen gas, H2. In other words, this is also diatomic. So H2, an element, a molecule of hydrogen gas. I could also, if I wanted to, take carbon. Carbon has more holes, if you can kind of see there. It's got holes all the way around it. So we can make more bonds with carbon than we can with hydrogen. There's only one hole on hydrogen. So if I wanted to, I could take carbon and bond the hydrogen there. And now I want to fill up all those holes. So I'm going to just keep putting more bonds on it. Put another guy on here. Can make 4 total bonds. All right. So as we can see here, carbon can make 4 total bonds with hydrogen. It needs 4 hydrogens and 1 carbon. So this would be a molecule of methane. This would be CH4, like cow farts, methane. Ooh, stinky. So we've got a molecule of CH4 in this case. Let's try something else. An element. An element, by definition, is a molecule, so 2 or more atoms, that have to be the same. They have to be the same. So let's do that one with oxygen. That's our red one. Oxygen has 2 holes, only 2. So we're going to put some bonds into our oxygen sphere. And for an element, it has to be the same. So I'm going to take another same red sphere and connect it together. So now I have an oxygen molecule that happens to be the element oxygen, and there's a double bond. There's actually 2 bonds between them. So bond, bond. So that's a double bond. Whereas here we have a single bond between the carbon and hydrogen from before that we were playing with. So this would be an element that happens to be diatomic, since oxygen falls in that 7 on the periodic table. A compound. A compound is where we have 2 or more atoms that are different and bonded together. Well, gee, we could pretty much just play with that all we want. So we could take our molecule of methane from before. Let's rip off one of those hydrogens and add and oxygen. Alrighty, so now we've got, okay, well, that's interesting. I've got a hole still open. We don't want that, so let's keep going. Why not? Let's take one of these guys and put a hydrogen over here. Alrighty, so now we have a compound. Notice that there are two or more. In this case, there are three different kinds of atoms, all bonded together, shown by these bonds. So what we have is a carbon, 3 hydrogens, and an OH. Whenever you have an OH group, that's an alcohol. That's an alcohol. So this would actually be an example of methanol. Methanol. A particle. Well, a particle is any of the things I just made. So again, if we had our oxygen element, our molecule of oxygen, this is a particle. Our hydrogen atom is a particle. My cool methanol compound is a particle. All of these are particles. That's your blanket term. What is matter then? I said at the beginning of the video that you matter, and I hope you do believe that, because truly you do. Each one of you are unique and on this earth for a purpose and a reason, and you do matter. Your life does matter. If you matter and you are living, you occupy space, you have mass, well, so do these molecules, so do these atoms, so do these compounds. They occupy space, just like atoms do with their big electron clouds. They have mass. Their protons and neutrons in the center of the nucleus is the majority of that mass. So they are matter. Matter is your fancy word for stuff. It's all that stuff. The stuff that makes up everything, i.e. the atoms that make up everything. So matter can have both chemical and physical properties. You can also change matter chemically or physically. And we're going to talk about this more in a following video. Please continue to watch for that video. But just really quickly here, if we have a white piece of paper, hopefully you agree with me that this piece of paper is made up of molecules, is made up of atoms, as are you. You are also made up of molecules and atoms. You are chemistry. You matter, just like this paper matters. So, if we have this matter of white paper and we can change it, you would agree with me that I could change the physical shape of this paper by folding it. Right? I changed its shape. So from before, this paper had a physical property of being thin, of being white, of being kind of nasty to touch if your fingers are a little dry, right? Those are all properties of the paper, and it has the ability to be changed physically by folding it. You can also change it physically, its physical appearance, by ripping it. You can change it as well now chemically. So paper has chemical properties as well. For example, paper is flammable, right? So since paper is flammable, that is a chemical property it has. Now, if I also happen to take this paper and light it on fire, which I don't know if you can see that, but there we go. Okay, so if we take this paper and we do light it on fire, then I'm also changing the chemical part of this paper. This paper cannot go back to being the way it was before. So notice that it's charred. There's like a whole black line going along this paper now. It is changed chemically. It's no longer white. It has a different shape. And there's a smell coming off of it, that burnt smell, burnt paper smell. So that is a physical and chemical example of properties and changes, which we'll talk about more in the next video. So hopefully you should be able to draw a thinking map similar to what I have behind me, And you should be able to fill out the similarities and differences. If you've never done one of these before, I highly recommend you do. Basically, what you want to do is everything on this side should only depict characteristics of an element. For example, everything on this side should only depict characteristics of a compound. Then the bubbles that are shared in the middle between the two words, you want to talk about the similarities between the two. So for example, the fact that compounds and elements are composed of 2 or more atoms means that they share in common the fact that they are both molecules. That's just to kind of get you started. Hopefully you can fill in the rest of it. Thanks for watching.
When the thing went quack, 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 you man were ducking.